There is a place in the high desert of West Texas where the sky meets the ground in a long, flat line of silence. No trees interrupt the horizon. No buildings crowd the edge of your vision. For miles in every direction there is only the Chihuahuan Desert, the dry grass, the ancient mountain shapes far in the distance. Above everything, a sky turns spectacular colors at dusk before darkening into one of the clearest star fields in North America. It is the kind of place where the absence of distraction becomes its own presence, where the land asks you to pay attention. And then the lights appear. Not the lights of the town behind you. Not the lights of distant cars on the highway to your right. Different lights. Lights that drift and hover over the dark desert floor, miles from where you stand. Lights that split into two and then merge back into one. Lights that blink out and reappear somewhere else. Lights that are sometimes white, sometimes amber, sometimes blue. Lights that move in ways that headlights do not move, in ways that lanterns do not move, in ways that have no obvious explanation. Lights that have been reported from this specific patch of desert since at least 1883. Before the automobile, before electricity reached this part of Texas, before there was anything out there to produce them. Welcome to Sleepy Science Stories. Tonight we are visiting one of the most persistently documented and scientifically frustrating mysteries in the American Southwest. The Marfa Lights, named for the small town in Presidio County, Texas that sits near their location. They are sometimes called ghost lights or mystery lights or, in older accounts, will-o'-the-wisps. They have been investigated by physicists and atmospheric scientists and geologists and engineers. They have been explained and re-explained and explained again. None of the explanations has fully satisfied everyone who has seen them. None of the explanations accounts for every aspect of what witnesses describe. The lights keep appearing, and the debate over what they are keeps going, and the town of Marfa keeps welcoming the visitors who come to see them. What makes the Marfa Lights scientifically interesting is not that they are supernatural. There is no reason to believe they are supernatural. Everything we know about physics suggests they have a physical cause. What makes them interesting is that the physical cause has proven genuinely difficult to nail down, not for want of effort. Serious scientific attention has been paid to this phenomenon for decades. Instruments have been deployed. Studies have been published, and yet the exact mechanism that produces the lights remains a matter of legitimate scientific debate. We are going to walk through that debate tonight. We are going to talk about where the lights appear, what they look like, what the historical record shows, and what the major scientific hypotheses propose. We are going to look honestly at the evidence for each explanation and at the problems each explanation leaves unresolved. And we are going to sit with the conclusion that uncertainty, when it is earned, is not a failure of science. It is science doing its job honestly. If you are already a listener of Sleepy Science Stories, thank you for spending your evenings here. If this is your first time, you are very welcome. These are the kinds of questions we like. Specific, documented, old enough to have accumulated evidence, strange enough to remind us that the world has not finished surprising us. The lights tonight are visible. Mitchell Flat stretches out dark and wide in the desert. The viewing platform is quiet at this hour. The mountains to the south are black shapes against a sky thick with stars. And somewhere out in the dark, over the creosote flats and the dry grass and the pale caliche soil, something is glowing. Let us go find out what. The Marfa Lights are not a legend in the vague, unverified sense of the word. They are a documented phenomenon with a public observation site maintained by the Texas Department of Transportation and a viewing season that draws thousands of visitors each year. They have been photographed and filmed. They appear in peer-reviewed scientific literature. They have been the subject of funded research projects at accredited universities. They are, in the vocabulary of anomalous phenomena, well attested. Whatever they are something real. The question is, which real thing? We will approach that question carefully and without shortcuts tonight. The Marfa Lights deserve the same rigor we would bring to any other scientific puzzle. The fact that they are strange does not mean we should abandon careful thinking. In some ways, the strangeness is a reason to think more carefully, not less. The world is full of phenomena that look impossible until the mechanism is understood. Sometimes understanding the mechanism takes longer than we expect. The Marfa Lights may be one of those cases. They may be simpler than they appear, or they may turn out to be genuinely novel. Either way, tonight we find out what we know, what we do not know, and where the boundary runs between them. Let the desert open around you. Let the night come down. Somewhere out past the darkness, and the silence, and the dry wind, something is glowing over the grass. Let us begin. There is a reason the Marfa Lights have survived a century of investigation without being fully explained. It is not because no one has tried. It is because the phenomenon is genuinely complex, genuinely specific to this place, and genuinely resistant to the tools that have been brought to bear on it so far. That resistance is not a sign of the supernatural. It is a sign that the natural world contains puzzles that require sustained, sophisticated effort to understand. The Marfa Lights are one of those puzzles. Tonight we bring to this puzzle the same approach we bring to every question on sleepy science stories: careful attention to the evidence, respect for uncertainty, willingness to follow the reasoning wherever it leads, even when it leads to a conclusion that is less tidy than we might prefer. The conclusion tonight is that the lights are real, that several explanations have partial support, that the complete explanation remains open, and that the open question is valuable in itself. Let that be enough for now. Let the openness be the point. Let your breathing slow and your body rest, and your mind release the need for resolution. The desert does not need the lights to be explained. The lights do not need to be understood. And tonight, neither do you. To understand the Marfa Lights, you first have to understand the geography of where they appear. Marfa is a small city in Presidio County, in the Trans-Pecos region of far west Texas. The elevation is around 4,900 feet above sea level. The landscape is high desert, specifically the northern edge of the Chihuahuan Desert, one of the largest deserts in North America. The terrain is a wide basin ringed by mountain ranges. To the south, across the Rio Grande, lies Mexico. To the east and west, the desert floor stretches flat and dry for long distances before hitting another ridge of mountains. The specific location where the lights appear most reliably is a flat expanse called Mitchell Flat. It lies east of Marfa, along US Highway 67, in the direction of the town of Alpine. The Texas Department of Transportation has built a formal viewing area here. It is a paved pull-off with a plaque, restrooms, and telescopes, about 9 miles east of Marfa, on the north side of the highway. On any given night, particularly in the summer and fall, you can find cars parked there and people standing in the dark, watching the desert. What they watch is a broad, dark plain stretching south of the highway, running toward the Chinati Mountains many miles in the distance. Beyond the highway lights and past the visible glow of Marfa behind you to the west, the plain is dark. No towns out there. No farms. No infrastructure of any visible kind. Just the desert floor and the distant mountains and the sky. And in that darkness, the lights appear. Witnesses describe them in fairly consistent terms across many decades of reports. The lights appear as glowing orbs or spheres, typically between basketball-sized and car-sized in apparent dimension when seen from the viewing area. They are usually white or yellowish-white, though some witnesses report orange, red, or blue coloration, especially when the lights appear to flicker or dim. They float above the desert floor, typically appearing anywhere from a few feet to several dozen feet above the ground. Estimating exact height at unknown distance is genuinely difficult. The behavior witnesses describe is what sets them apart from ordinary light sources. The lights move laterally across the field of view, sometimes slowly and sometimes with unexpected speed. They split, a single light dividing cleanly into two lights that then drift apart from each other. They merge, two lights approaching each other and combining into one. They pulse, brightening and dimming in rhythms that do not correspond to any obvious mechanical source. They disappear and reappear, sometimes in the same spot and sometimes at a distance from where they vanished. Photographs and video exist. Some of these clearly show car headlights on distant roads. They move in a linear fashion, brighten and dim on predictable curves, and correspond to known highway locations south of Mitchell Flat. Experienced observers note that the motion pattern of highway traffic is distinct from the behavior of the lights classified as genuinely anomalous. Not every light seen from the viewing area is mysterious. Experienced observers, locals, and researchers distinguish carefully between the ordinary highway lights visible on the roads running through the region and the lights that exhibit unusual behavior. The genuine mystery lights are reported less frequently than first-time visitors sometimes hope. Some people stand at the viewing area for hours and see only highway traffic. Others report seeing the classic orb behavior quickly after arrival. The lights are real. They are not nightly guaranteed. They are not easily dismissed. The most commonly described episodes last from seconds to several minutes. The lights do not approach the highway or the viewing area. They remain in the middle distance, over Mitchell Flat, apparently indifferent to observation. They do not respond to signals. They do not communicate. They glow, they move in their distinctive pattern, and eventually they are gone. And people who have seen them once tend to return. The landscape itself contributes to the experience. The Chihuahuan Desert at night is extraordinarily dark and quiet by the standards most modern people experience. The air is dry, and the sky is clear on most nights. The flat horizon gives the eye no reference frame for judging distance or scale. In those conditions, lights of uncertain origin moving in unexpected patterns produce a strong impression that does not diminish easily in the telling. The viewing area is not a place that makes you feel you are watching something mundane. The desert at night has its own quality of attention. It asks something of you. What the viewing platform also offers, beyond the lights themselves, is a particular kind of sensory experience that is increasingly rare in modern life. The absence of light pollution over Mitchell Flat is profound. On a clear night, the Milky Way is visible as a dense luminous band across the sky, not as a faint smear but as a structure with depth and texture, the way it appeared to every human being before the invention of electric light. The stars are numerous enough that familiar constellations become harder to find because they are surrounded by thousands of stars that city dwellers never see. The sky itself becomes strange in the best possible way. In that context, the mystery lights are part of a broader experience of a sky and a landscape that most modern people have lost access to. The lights are unusual, but the whole night is unusual out there. The darkness is unusual. The silence is unusual. The air is unusually dry and unusually clear. You are standing at 4,900 feet in the Chihuahuan Desert on a clear night. The universe is doing what it has always done, being incomprehensibly large and mostly dark and occasionally very strange. The lights fit into that context. They are not an intrusion. They are a feature of a landscape that has always been larger and stranger than its inhabitants. The documented history of the Marfa Lights begins in 1883, which is the date most researchers cite as the earliest formal record. In that year, a young cowhand named Robert Reed Ellison was driving cattle through Paisano Pass. He was east of what would become Marfa when he noticed flickering lights in the distance over the desert. He assumed they were Apache campfires. He was experienced enough in the region to know the area was still subject to Apache presence at that time. He watched the lights carefully. The next day, he asked local residents about the Apache camps he had seen. The local residents told him there were no Apache camps in that direction. Nobody knew what he had seen. Ellison's account was passed down through his family and eventually reached researchers collecting the early history of the lights. It is the oldest specific account with a named witness and a documented date. But there are reasons to think the phenomenon is considerably older. The indigenous peoples of the Trans-Pecos region have their own histories of lights in this desert. The Comanche and Apache peoples who inhabited and crossed this territory for centuries before European settlement had accounts of mysterious lights in the area. These accounts vary in their details and their interpretation. Some describe the lights in spiritual terms, as manifestations of natural power or ancestral presence. Some describe them in more practical terms, as unusual phenomena to be noted and avoided. What the accounts share is the basic observation that lights appear over this particular stretch of desert, and have done so for as long as living memory reaches. The period from the late 19th century through the early 20th century produced multiple independent witnesses. Ranchers in the Marfa Basin reported seeing unexplained lights. Soldiers stationed at nearby Fort Davis, one of the significant frontier military posts in the Trans-Pecos region, recorded accounts of lights over the desert. A woman named Hallie Stillwell became a well-known figure in the region as a rancher and journalist. She wrote about seeing the lights in the 1930s and continued documenting accounts of them for decades. Her accounts describe lights that moved, split, merged, and disappeared in a manner consistent with what current visitors report. The Second World War brought an unexpected chapter in the history of the Marfa Lights. The Army Air Forces established Marfa Army Airfield during the war, using the flat terrain and clear skies for pilot training. Trainee pilots reported seeing unusual lights in the desert during night flights. Some of these reports made it into official records. The base personnel were not in a position to explain the lights, and the reports were filed without resolution. After the war, the base closed. The lights continued. The post-war decades brought more documentation. The development of Highway 67 made the viewing area accessible. The growth of the American interstate system brought more witnesses from outside the region. By the 1970s and 80s, the Marfa Lights had accumulated enough attention to produce a small local tourism economy and to attract scientific interest from researchers outside Texas. The key point that the historical record makes clear is this: the lights were seen before automobiles existed in the region. They were seen before electricity reached the Trans-Pecos. They were seen before any of the roads or infrastructure that now exist in Mitchell Flat were constructed. Whatever the Marfa Lights are, they cannot be entirely explained by pointing to modern human activity in the area. The history does not permit that shortcut. Any explanation that relies on modern vehicles and modern roads must still account for what Ellison saw in 1883, and for what the frontier soldiers saw in the 19th century, and for what the Comanche and Apache described before that. The lights predate the explanation. That is the central difficulty. The period before written records presents a methodological challenge that historians of science encounter frequently. We cannot interview the Apache warriors who may have watched the same lights from the same desert. We cannot ask the Comanche travelers who crossed Mitchell Flat on paths worn into the Kalish over generations. What we have is the collected testimony of people who came after, who heard stories, who wrote them down imperfectly, and who passed them forward. That testimony is imperfect data, but imperfect data is still data, and it points consistently in the same direction. There were lights here before Robert Reed Ellison saw them in 1883. There were lights here before anyone thought to write about them. The desert was producing its mystery long before anyone arrived to name it. The early settler accounts from the 1880s and 1890s are particularly valuable. They come from people who had practical reasons to pay close attention to lights in the desert at night. In that era, the Trans-Pecos was still a frontier in the literal sense. Cattle drives, Apache conflict, and the isolation of the high desert made nighttime light a matter that could carry life or death implications. These were not casual observers looking for wonder. They were working people, ranchers and cowboys and soldiers, who needed to know what was happening around them. When they reported lights that they could not explain after careful investigation, that report carried weight precisely because they were motivated to find an explanation and could not. The consistency between the 19th century accounts and present-day observations is one of the strongest arguments for taking the phenomenon seriously as a scientific question. The lights that Ellison saw in 1883 behaved the way the lights that current visitors see at the viewing platform behave. Same location, same basic description, same inability to explain. Whatever is producing the lights is not a product of modernity. It is a product of this specific landscape, operating on whatever schedule the landscape dictates, indifferent to who is watching or what century they inhabit. What the historical record cannot tell us is the inner experience of the people who first noticed the lights over Mitchell Flat. No archival research will ever recover that. They had no framework for understanding what they saw. A Comanche warrior crossing the desert before dawn, seeing something glow and drift and split over the flat grass. A Spanish colonial explorer, months from home, watching lights move in a country that offered no reassurance and no explanations. An Apache hunter who had traveled these routes 100 times would have known this was different. He would have known with the certainty of someone who lives by accurate perception. This had no name. What did they make of it? The lights offered no clues then and offer no fewer clues now. They glowed and moved and disappeared, the same way they glow and move and disappear tonight. The mystery predates every one of its investigators by a very long time. Among the many things that make the Marfa Lights scientifically interesting, the details of their behavior under direct observation are among the most puzzling. Careful researchers who have spent many nights at the viewing area with good optical instruments describe the lights in terms that do not map cleanly onto any single known phenomenon. They are not simply distant lights seen through heat shimmer. They are not simply car headlights. The behavior includes specific attributes that any serious explanation must account for. The splitting and merging behavior is probably the most frequently cited and the most difficult to explain. Multiple independent observers, on multiple occasions, have reported watching a single light divide into two distinct lights that then move apart from each other. These two lights then sometimes approach each other and combine back into a single light. This behavior has been captured on video. It does not correspond to what you would expect from a car approaching a curve and having its two headlights become visible sequentially, which is one common dismissal. The splitting is lateral, a single orb becoming two orbs side by side, not a single moving light becoming two lights on different angular paths. The lateral movement of the lights does not follow the linear paths you would expect from vehicles. Cars follow roads. Roads in that region run in fairly straight lines across the flat terrain, with gentle curves in places. The mysterious lights, as distinguished from the ordinary highway traffic, also visible from the platform, do not follow any known road alignment. They drift across the field of view in directions that do not correspond to the road network south of Mitchell Flat. Researchers with topographic maps have attempted to correlate observed light tracks with known roads. In some cases, the movement does not match any road location on any available map. The pulsing behavior is another attribute that resists simple explanation. Witnesses describe the lights brightening and dimming in rhythms that feel distinct from the Doppler effect. A vehicle headlight brightens as it approaches and dims as it moves away. The pulsing described here is different. The pulsing is sometimes described as more like a heartbeat, a regular or semi-regular brightening and dimming that occurs while the light is stationary or moving slowly sideways. A vehicle headlight does not pulse when the vehicle is moving laterally at constant speed. The lights sometimes do. Color is a less universal, but still notable characteristic. The majority of reports describe white or yellowish-white lights. A significant subset describes orange or amber coloration. A smaller number of reports mention blue or bluish-white. Some witnesses describe color changes within a single observation episode. A light that begins white and shifts toward amber, and then back again. This color variation is consistent with some of the scientific hypotheses that have been proposed and will become relevant when we examine those hypotheses in detail. The temperature conditions appear to influence the frequency and clarity of observations. The lights are reported more often on warm nights and during periods of weather change. They are less commonly reported during cold, stable atmospheric conditions. This association with temperature has been one of the more productive clues for researchers trying to understand the physical mechanism at work. The distance of the lights from the viewing platform is genuinely uncertain. Because the lights appear over flat terrain with no fixed reference objects of known size, judging their distance is difficult for an observer standing at the platform. Some researchers have attempted triangulation using observations from multiple points simultaneously. Their estimates place the lights at distances ranging from a few miles to perhaps 10 or more miles from the platform. At those distances, the apparent size of the lights suggests they are producing significant illumination. A small candle flame or a modest chemical fire would not be visible at several miles at the brightness witnesses report. Whatever is producing the lights has some real power behind it. The apparent height of the lights above the ground is one of the more interesting details in the observational record. Most witnesses describe the lights as appearing to float somewhere between ground level and perhaps 20 or 30 feet above the desert floor. They are not high in the sky. They are low, close to the ground, hovering over the flat plain. This low altitude is consistent with several of the scientific hypotheses that have been proposed. Atmospheric temperature inversions are most pronounced in the layer immediately above the ground. Electrical discharges from tectonic stress would be concentrated near the surface, where the electrical field gradient is strongest. Ball lightning, in the accounts from other parts of the world, is typically reported at low altitude, near the height of a person or a fence post. The fact that the lights remain consistently close to the ground across more than a century of reports is a useful constraint on hypotheses. Any explanation that would predict lights at high altitude, like reflections from high-altitude atmospheric layers, is less consistent with the observational record. The lights are a ground-level phenomenon. They occur where the air meets the earth. Meteorologists and atmospheric physicists call this the boundary layer. It is the layer most directly influenced by surface conditions, and it receives considerable scientific attention. The viewing experience from the platform also involves a psychological dimension worth acknowledging. Most visitors to the Marfa viewing area arrive with some awareness of the light's reputation. They come expecting to see something unusual. This expectation creates a perceptual context that is worth being honest about. In psychology, this is called priming, the tendency of prior expectations to influence what we perceive. Primed observers are more likely to classify ambiguous stimuli as significant. A distant car headlight that might be dismissed by an unprimed observer becomes a candidate mystery light to a visitor who has driven hours to see the phenomenon. The researchers who take the Marfa Lights seriously are aware of this problem and attempt to design observations that control for it. The fact that cameras capture the same behavioral characteristics that trained human observers report suggests that the phenomenon is not merely perceptual. But the psychological context of observation is always worth keeping in mind when evaluating witness testimony. The most geologically grounded explanation for the Marfa Lights involves the structure of the Earth beneath Mitchell Flat itself. The Trans-Pecos region of Texas is geologically active in a specific sense. It sits at the western edge of the North American craton. There, the continental crust has been stretched and faulted over millions of years as the Basin and Range Province formed. The region is crossed by faults, some minor and some significant. The Chinity Mountains to the south of Mitchell Flat are the remnants of volcanic activity, primarily from the Eocene epoch, roughly 40 to 50 million years ago. The ground beneath the Marfa Basin is not the simple, inert rock layer that flat desert terrain might suggest. It is a complex geological system with active fractures, mineral-rich substrates, and the slow but continuous stresses that come with being at the boundary of large tectonic features. This geological setting provides the foundation for what is sometimes called the piezoelectric hypothesis for the Marfa Lights. Piezoelectricity is a well-documented physical phenomenon. Certain crystalline materials, most notably quartz, generate an electrical charge when subjected to mechanical pressure. The rocks of the Trans-Pecos region contain significant quantities of quartz and other piezoelectric minerals. When tectonic stress causes these rocks to shift, compress, or fracture along fault lines, the piezoelectric effect generates electrical energy. That electrical energy can, in principle, produce a variety of light-emitting effects in the air above the stressed rock. Ball lightning, plasma discharges, and other luminous phenomena have been proposed as possible results of this process. The specific proposal for the Marfa Lights under this framework runs roughly as follows. Ongoing tectonic stress in the fault systems beneath Mitchell Flat periodically causes rock to compress or fracture. This compression generates electrical charge in the quartz-bearing strata. That electrical charge accumulates until it produces a luminous discharge, visible from the surface as a glowing orb. The discharge floats near the ground because the electrical field is concentrated in the lowest layers of the air above the fault. As the electrical conditions change, the discharge can divide, producing two orbs from one. As the fault stress shifts, the discharge can move laterally along the fault line. When the energy is exhausted, the light vanishes. This explanation has genuine scientific appeal. It connects the lights to a known physical mechanism. It explains the geographic specificity, why the lights appear over this particular flat basin and not everywhere in the region. The fault structure beneath Mitchell Flat is specific to that location, and a phenomenon driven by fault zone stress would be expected to appear only where the relevant faults are present. The explanation also accounts for the intermittent nature of the lights. Tectonic stress is not constant. It builds and releases over time on irregular schedules, which would produce lights on some nights and not others. Researchers have noted that some reports of light phenomena elsewhere in the world are associated with seismic activity. Earthquake lights, which are luminous phenomena observed before and during earthquakes, are a documented if poorly understood phenomenon. Reports of colored lights, glowing columns, and floating orbs before or during major earthquakes have been collected from multiple locations around the world, including Japan, Peru, and the Pacific Northwest. If earthquake lights represent a real physical phenomenon driven by piezoelectric effects in stressed rock, the Marfa Lights could be a lower energy version of the same mechanism. Rather than the acute stress of a major earthquake, the source would be chronic low-level tectonic stress. The challenges for this hypothesis are also real. The strongest version of the piezoelectric argument requires the electrical energy to do something unusual in the atmosphere above the fault. Creating a visible plasma discharge from fault-generated electricity is theoretically possible, but has not been directly demonstrated in field conditions matching Marfa. Seismometers in the region have not consistently detected movement on the nights when the lights appear. Small-scale fault creep can occur without producing measurable tremors, so this absence is not conclusive, but it is a complication. The geological hypothesis provides a plausible starting point. It does not yet provide a complete, testable, confirmed account. The geological hypothesis has one more dimension worth exploring: the relationship between the Marfa region and broader patterns of tectonic activity in the western United States. The Basin and Range Province, of which the Trans-Pecos is the eastern edge, is one of the most tectonically dynamic regions in North America. The crust here has been stretching since roughly 30 million years ago, pulled apart by forces associated with the movement of the Pacific and North American plates. That stretching has produced the alternating basins and mountain ranges that give the province its name. It has also produced a network of faults, large and small, that continues to adjust slowly to the evolving stress field. What this means for the Marfa Lights hypothesis is that the tectonic context is not hypothetical. There genuinely are active fault systems in the Marfa Basin. The question is whether those faults produce enough stress concentration, often enough, in the right locations, to generate the piezoelectric effects or other electromagnetic phenomena that could produce visible light. The answer to that question requires detailed seismological and geophysical data from the specific area of Mitchell Flat, and that data has not been comprehensively collected and published. Researchers who find the geological hypothesis compelling point to the parallels with earthquake light reports. Researchers who are skeptical point to the absence of measured seismic correlation. Both sides are working with incomplete information. The geological hypothesis is also worth considering in relation to the specific topography of Mitchell Flat itself. The flat basin sits in a structural depression, surrounded by elevated terrain. This topography creates a contained space in which any atmospheric or electromagnetic effects produced by the geology would be concentrated rather than dispersed. If the faults beneath Mitchell Flat were producing electrical energy, that energy would propagate upward into an enclosed air mass bounded by mountain ridges on multiple sides. The effects, if any, would be concentrated in the basin rather than spread across the open desert. This containment effect might explain why the lights appear in this specific basin and not in the broader surrounding desert. The regional geology is similar for many miles in every direction. The topography is not. The most widely discussed scientific explanation for the Marfa Lights does not invoke geology or plasma at all. It invokes the atmosphere. The core of the atmospheric explanation is a phenomenon called temperature inversion, combined with the effect of refraction on light traveling through air layers of different temperatures and densities. Under normal atmospheric conditions, air temperature decreases as you move upward from the ground. Warm air is less dense than cool air. This normal temperature pattern, which meteorologists call the standard lapse rate, tends to be disrupted on clear, calm nights in the desert, when the ground radiates heat quickly after sunset, as desert terrain does very efficiently. The air immediately above the ground cools rapidly, while air at higher elevations remains relatively warm. The result is a layer of cold, dense air near the surface capped by a layer of warmer, less dense air above. This is a temperature inversion. When light travels through air of varying density, it bends. This is refraction. You have seen it when a straight stick appears bent when partially submerged in water. Water is denser than air and bends the light more strongly. The same principle applies when light travels through air of varying density. Light from a distant source traveling horizontally through a temperature inversion can be bent downward. It can appear to float above the ground. It can seem to come from a location entirely different from its actual source. This effect is responsible for desert mirages, the shimmering false lakes that appear on hot highways, and the visual distortions visible above hot pavement on summer afternoons. The atmospheric hypothesis argues that the lights are ordinary light sources being refracted and distorted by temperature inversions. Most likely car headlights on the highways that run through the Chihuahuan Desert south of Mitchell Flat. Highway 67 runs south from Marfa and crosses the desert toward the town of Presidio on the Rio Grande. Other ranch roads and county roads cross the region at various angles. At night, Vehicles on these roads produce light that travels horizontally across the flat basin. If a temperature inversion is present, that light can be ducted through the dense cold layer near the ground. It bends in ways that make it appear to hover, drift, split, and merge when seen from a fixed point miles away. The splitting behavior would correspond to a single vehicle's headlights. They appear as one light at some angles of refraction and two lights at others, as the geometry of the inversion layer shifts. The lateral drift would correspond to the vehicle moving along the road. The disappearance would correspond to the vehicle moving around a curve, through a road cut, or out of the sight line created by the inversion. The pulsing would correspond to variations in the inversion layer itself. In 2004, a team of physics students from the University of Texas at Dallas conducted an investigation of the Marfa Lights. They positioned instrumented vehicles in known locations along the southern highways on nights when lights were reported. They found a correlation between the vehicle positions and the reported lights. Their conclusion was that automobile headlights refracted through atmospheric inversion layers explained the phenomena they observed on the nights of their study. The atmospheric explanation is tidy and physical. It requires no unusual geology. It requires no plasma physics. It requires only weather conditions that are common in the trans-pecos and the well-understood physics of light refraction in layered air. The association between the lights and warm, clear, calm nights fits the inversion explanation, because those are exactly the conditions under which desert inversions form. The correlation between inversion-favorable weather and light frequency is one of the strongest pieces of supporting evidence this explanation has. The atmospheric hypothesis also benefits from some additional context about the specific meteorology of the Marfa Basin. The Trans-Pecos region at 4,900 feet elevation sits in an unusual thermal environment. The days are often hot by late spring and summer, with solar heating creating strong vertical mixing in the lower atmosphere. But once the sun sets, the high desert radiates heat very efficiently upward into the dry air. The temperature can drop 20 degrees or more between afternoon and midnight. This rapid cooling creates exactly the surface inversion conditions that the atmospheric hypothesis requires. The air near the ground cools faster than the air above it, producing a density gradient that bends horizontal light rays. The flat terrain of Mitchell Flat amplifies this effect. Over uneven terrain, the surface cooling is uneven, and the inversion layer is irregular, which tends to break up refraction effects before they become dramatic. Over flat terrain like the basin floor, the cooling is uniform, and the inversion layer is consistent across large horizontal distances. Light entering the inversion from a distant source can travel many miles while being continuously guided by the density gradient. The cumulative bending adds up to significant displacement by the time it reaches an observer at the viewing platform. The flat terrain is not incidental to the atmospheric hypothesis. It is one of the conditions that makes the phenomenon possible at the scale and frequency that Marfa exhibits. The highways south of Mitchell Flat also deserve specific description for understanding the atmospheric explanation. Highway 67 south of Marfa runs through the desert toward Presidio, roughly 40 miles to the south-southwest. At night, vehicles on this highway produce headlights that shine roughly horizontally across the flat basin, aimed approximately in the direction of the Marfa viewing area. A temperature inversion over Mitchell Flat would intercept these lights and potentially duct them toward the platform. The apparent brightness of the refracted lights would depend on the strength of the inversion and the original brightness of the headlights. Modern LED headlights are significantly brighter than the incandescent headlights of earlier decades. The refracted headlight version of the lights might actually be more dramatic now than it was in the 1980s and 1990s, when scientific interest was first building. If the atmospheric refraction of headlights explanation fully resolved the Marfa Lights mystery, there would be no mystery to discuss tonight. The explanation accounts for much. It does not account for everything. The most significant problem is the historical record. The 1883 account of Robert Reed Ellison describes lights over Mitchell Flat that predate the automobile and predate any paved road through that desert. The indigenous accounts of lights in the same region predate European settlement entirely. The reports from the late 19th century cannot be explained by car headlights because there were no cars. The atmospheric refraction of light from lanterns or campfires is theoretically possible. But the behavioral descriptions in those accounts are another matter. The splitting, the merging, the lateral movement are not consistent with lanterns carried by people on foot or on horse across open terrain. Proponents of the atmospheric explanation respond that historical accounts are imprecisely recorded. Descriptions of unusual behavior may reflect observer confusion rather than precise optical information. Oral traditions transmitted across generations before being written down are unreliable data. These are fair methodological points. Historical testimony is genuinely imperfect, but the consistency of the behavioral descriptions across very different witnesses and very different time periods is harder to dismiss than individual accounts. People from the 1880s, the 1930s, the 1950s, and the present are describing the same specific behaviors in the same specific location. The consistency across more than a century of independent observation is difficult to dismiss. There is also a geometric problem with the headlight explanation. Researchers who have carefully mapped observable highway locations against the reported directions of the mystery lights have found that not all lights align with road corridors. The highways south of Mitchell Flat run at specific angles and in specific locations. Lights that appear in directions where no road exists cannot be explained by headlights on those roads, regardless of how dramatic the atmospheric inversion. There is also the testimony of experienced local observers. Long-term Marfa residents who have spent many nights at the viewing area make careful distinctions between the highway lights and the mystery lights. The highway traffic, they say, is visible and recognizable. It moves in predictable paths. It brightens and dims on curves in consistent ways. The mystery lights, when they appear, are qualitatively different. They move in directions no road runs. They split and merge in ways that vehicles do not. This distinction, reported by people who have observed both phenomena many times over many years, carries evidential weight that should not be discarded without good reason. The most honest assessment is that the atmospheric explanation is probably correct for a significant proportion of what observers see from the Marfa viewing area. On many nights, much of what appears is likely refracted highway light, but some events, particularly those that occurred before automobiles and those that exhibit behaviors inconsistent with known road alignments, remain unexplained. The honest scientific position is that the atmospheric explanation is important. It is probably the dominant cause, and it is not the complete story. One more dimension of the problems with the atmospheric explanation deserves careful attention. The question of what experienced local observers actually report. The distinction between being experienced and being unbiased is worth noting here. Long-term Marfa residents who have spent many nights at the viewing area are not unbiased observers. They live in a community where the lights are a source of local pride and economic activity. Their expectations have been shaped by years of watching and by the community's collective interpretation of what they are seeing. This bias could work in either direction. It could make them more likely to classify ordinary highway lights as mysterious, or it could make them more skeptical and better calibrated, capable of distinguishing the familiar from the genuinely unusual precisely because they have seen both so many times. The honest assessment is that experienced local testimony is valuable, but not definitive. It provides information. It does not settle the question. What would settle the question more conclusively is the kind of systematic instrumented observation that has not yet been conducted. Imagine placing 10 observers at 10 positions around Mitchell Flat on every clear night for a full year, each equipped with a camera, a GPS logger, and a spectrometer. All observations correlated with highway traffic data, weather data, and seismometer readings. That would generate a dataset worth analyzing rigorously. You could determine what fraction of observed light events correlated with highway traffic on specific roads. You could determine whether the residual events, those that do not correlate with traffic, cluster in particular directions, occur under particular weather conditions, or have spectral characteristics distinguishable from headlights. That analysis would not necessarily close the question entirely, but it would close it much further than it currently is. The fact that this study has not been done is a comment on how scientific resources are allocated, rather than a comment on the importance of the question. The Marfa Lights are a real documented phenomenon with a genuine unresolved mechanism. They deserve better investigation than they have received. The tools exist. The phenomenon persists. The gap between them is funding and institutional willingness. The pre-automobile historical accounts also raise a more fundamental question about the completeness of the atmospheric explanation as a scientific framework. Even if refracted headlights explain every light event that occurs today, we are left with a separate unresolved question. What did the 19th century observers see? If the accounts are accurate, whatever produced the 19th century lights was generating the same behavioral characteristics from a non-automotive source. The splitting, the merging, the drift, all present before any car drove those roads. That means the behavioral characteristics, the splitting, the merging, the lateral drift, are not unique to refracted headlights. They can be produced by something else. The question of what that something else is remains entirely open, even if every modern sighting is successfully explained by the atmospheric hypothesis. The history and the present may have different explanations. Both explanations are still needed. The Marfa Lights have attracted genuine scientific fieldwork, not just popular curiosity, and the results of that fieldwork are worth examining carefully and honestly. The most cited formal study is the 2004 investigation conducted by students in the physics program at the University of Texas at Dallas, working under faculty supervision. The methodology involved positioning vehicles with headlights on the southern highways on target nights. Researchers compared vehicle positions to the reported positions of lights seen from the platform. The correlation found was strong enough for the researchers to conclude that automobile headlights explained the phenomena they observed on the specific nights of the study. What the study does not address is the pre-automobile history and the full range of light behaviors described by experienced observers over decades. The study was conducted over a limited number of nights, and was designed specifically to test the headlight hypothesis. It was not designed to characterize all phenomena present in the area across all conditions and all seasons. Its conclusions are valid for what it measured. The problem comes when popular accounts treat those conclusions as definitive for all Marfa Light events, which is more than the study claimed. Separate efforts by local researchers and amateur investigators have involved cameras, spectrometers, and GPS-coordinated triangulation equipment deployed over many nights. Some of this work has produced interesting data. Light events have been recorded that do not correlate with known highway locations. Distance estimates using triangulation from two simultaneous observation points have placed some lights at locations where no paved or officially mapped road exists. Researchers have also attempted spectroscopic analysis of the lights, trying to identify their emission spectrum. The emission spectrum of a light source reveals its physical mechanism. Hydrogen flame produces a different spectrum than burning hydrocarbons. Plasma discharge produces a different spectrum than refracted incandescent, or LED light. The spectroscopic data collected so far has been limited by the distance to the lights and the sensitivity of instruments available to researchers working without major funding. No definitive spectroscopic identification has been published. The lights are far away. The signal is faint, and the instruments available without institutional support are not optimized for this specific application at these distances. Atmospheric monitoring has been conducted to correlate light appearances with weather conditions. The association between temperature inversions and light sightings has been examined. Some researchers report a strong correlation. Others report light events that occur on nights without a measurable inversion. The correlation is imperfect and inconsistent, which fits a picture in which atmospheric refraction explains some events and a different mechanism explains others on different nights under different conditions. What does not yet exist is a comprehensive, well-funded, long-duration study conducted with modern instruments from multiple fixed positions with simultaneous data collection. The phenomenon has not attracted the level of institutional scientific investment that would allow truly systematic observation. Part of the reason is that the lights do not fit cleanly into any established funding category. Part of the reason is that cultural associations with mystery make some researchers reluctant to engage publicly. The scientific picture therefore remains honestly incomplete. Better work could be done. It has not yet been done. The broader context of anomalous light research gives some useful perspective on where the Marfa investigation stands relative to comparable phenomena elsewhere. The Hestelen lights in Norway provide the most instructive comparison. Hestelen is a small valley in central Norway where unusual lights have been reported since at least the early 20th century. Activity was particularly intense in the early 1980s, when sightings were reported multiple times per week. This high frequency attracted the attention of Norwegian scientists, who established a formal research project called Project Hestelen in 1983. The project eventually installed automated monitoring equipment in the valley and has been collecting data for decades. The lights there have been photographed, filmed, tracked with radar, and analyzed spectrographically. The research has not produced a single unified explanation. Instead, it has established that the lights are real and involve multiple physical phenomena. Some events are explained by known mechanisms. Others are not. The valley's specific geology appears relevant to their occurrence. The key lesson from Hestelen for Marfa is not the specific conclusions but the research model. Long duration, instrumented, systematic observation with multiple simultaneous data streams can make progress on phenomena that resist simple explanation. The Hestelen project did not close the mystery. It refined it, narrowing the space of plausible explanations and establishing facts that any future explanation must account for. That kind of progress is exactly what Marfa needs and has not yet received. The broader literature on anomalous light phenomena also reveals a consistent pattern across different locations and geological settings. Flat, open terrain is a recurring feature. Proximity to fault systems or geologically active zones is common. Association with specific weather conditions, particularly clear nights with temperature inversions, appears repeatedly. The family of phenomena is real and widespread. Marfa is one example among many. What makes Marfa notable is the combination of well-documented historical records, accessible viewing location, sustained public interest, and the specific character of the Trans-Pecos geology. If any mystery light location deserves a comprehensive modern investigation, Marfa has a strong claim. The question of why no comprehensive study has been done deserves a direct answer, because it reflects something important about how science allocates attention and resources. Scientific funding tends to flow toward problems that fit recognized categories. There are funding streams for atmospheric science, for geophysics, for electrical engineering, and for many other disciplines that could contribute to understanding the Marfa Lights. But the Marfa Lights do not fit cleanly into any of these categories, which means there is no obvious funding home for a comprehensive investigation. A grant proposal focused on the Marfa Lights would face a review committee asking whether the phenomenon justifies the investment. Given competing priorities in atmospheric science, geophysics, and other fields, the answer is often no. Not because the phenomenon is unimportant, but because other phenomena are more clearly aligned with established research priorities. There is also the question of career risk for researchers who engage publicly with phenomena associated with popular mystery. Scientists who study the Marfa Lights or similar phenomena risk being associated with paranormal investigation in the public mind. That association carries a stigma in academic science, regardless of the rigor of the actual research. This stigma is unfair and counterproductive, but it is real. The result is that genuinely interesting natural phenomena go understudied because the social incentives of academic science push researchers away from them. The Marfa Lights are a victim of this dynamic as much as anything else. Among the physical phenomena proposed as explanations for the Marfa Lights, ball lightning occupies a unique position. It is the explanation that most scientists find plausible as a supplement to the atmospheric hypothesis. It is also the explanation most scientists find frustrating because ball lightning itself remains poorly understood. Ball lightning is a documented but inadequately explained phenomenon. Reports of ball lightning go back centuries and come from every inhabited continent. Witnesses describe luminous spheres of various sizes, typically between golf ball and several feet in diameter. They float through the air, sometimes at low altitude, persisting for seconds to minutes. Then they disappear, sometimes with an audible sound and sometimes silently. Ball lightning has been reported indoors and outdoors, during thunderstorms, and in clear weather, by pilots, sailors, scientists, and ordinary people. The consistency of the basic description across cultures and centuries is striking enough that dismissing it entirely requires more confidence than the evidence supports. What ball lightning is, physically, remains unclear despite many serious proposals. Plasma maintained by atmospheric electromagnetic fields, microwave energy focused by unusual atmospheric conditions, combustion of atmospheric gases in a sustained sphere. None of these hypotheses has been confirmed experimentally. Ball lightning has never been reliably reproduced in a laboratory, though some researchers report producing phenomena that share some of its characteristics. It remains one of the unresolved puzzles of atmospheric physics. If ball lightning is real and its mechanism involves electromagnetic effects in the lower atmosphere, then the geology of the Marfa Basin becomes relevant again. The same tectonic stress mechanisms proposed in the piezoelectric hypothesis could generate electromagnetic conditions that initiate ball lightning. The lights would then be ball lightning created by ground-based electrical effects rather than conventional lightning activity. This would explain their appearance on clear nights without storms. Ball lightning from thunderstorms is most commonly reported during or near storm activity. Ball lightning from tectonic sources would appear whenever ground stress is present, regardless of weather. The Marfa Lights also have company around the world. Similar phenomena have been reported in many locations, and the family resemblance is instructive. The Min Min lights of the Australian outback are reported over flat desert terrain. They have the same quality of appearing to drift and float at a distance without approaching observers. The will-o'-the-wisps of European marshes and bogs are now mostly explained as methane and phosphine combustion from decaying organic matter. The classic accounts go well beyond simple static flames, however. The Hestilin lights of Norway, visible over a mountain valley since at least the early 20th century, have attracted sustained scientific attention and remain the subject of ongoing investigation. The Hestilin phenomenon is particularly instructive for thinking about Marfa. Norway's Hestilin Valley has been the site of formal scientific research for decades, including a permanent monitoring station. The lights there have been measured, filmed, and analyzed. They have been found to involve multiple phenomena, some explained by known atmospheric and chemical mechanisms, and some not yet fully characterized. The research has not closed the mystery. It has refined it. What was a single puzzling phenomenon has been sorted into multiple categories, some solved and some still open. The lesson for Marfa is that the lights may not be one thing. They may be several different physical phenomena that look similar from the viewing platform and require different explanations for different events on different nights. The relationship between the Marfa Lights and the broader question of unresolved atmospheric phenomena is worth dwelling on for a moment. Physics, as a discipline, has an excellent track record of explaining natural phenomena once the right observations are available. The history of physics is largely a history of apparently mysterious things turning out to have elegant underlying mechanisms once those mechanisms were properly characterized. This gives physicists and physics-adjacent scientists a reasonable prior expectation that apparently mysterious natural phenomena will turn out to have comprehensible physical causes. That prior is warranted. It is probably correct in the case of the Marfa Lights. Whatever the lights are, they are almost certainly doing something that quantum mechanics and electromagnetism and fluid dynamics can eventually describe. But the prior should not become a prejudice that closes questions before they are properly investigated. The history of physics also contains examples of phenomena that were dismissed as too strange to investigate, phenomena that turned out to be real and important. Ball lightning was treated as collective misperception by many physicists for most of the 20th century. Earthquake lights were similarly dismissed. In both cases, the dismissal was premature. The phenomena turned out to be real, and the refusal to investigate them seriously delayed understanding. The appropriate attitude toward the Marfa Lights is therefore neither credulity nor dismissal. It is the same attitude physics brings to any unresolved problem. Take the observational record seriously. Design investigations that distinguish between competing hypotheses. Collect the data. Follow where it leads. The lights have been waiting more than a century for that investigation. The desert is patient. The physics is still there to be done. Whoever finally provides a complete, tested, published explanation for every category of Marfa Light event will have added something real and permanent to our understanding of this planet. That is not a small thing. That is exactly the kind of contribution science exists to make. The question is open. The instrument is ready. The investigation awaits. There is a third category of explanation worth mentioning, even though it is the least scientifically developed: the possibility that the lights involve natural gas or other chemical combustion phenomena. The Trans-Pecos region has hydrocarbon geology. Permian Basin oil and gas production occurs to the northeast, and there are geological formations in the broader region that contain hydrocarbons. Natural gas seeping slowly through faults and fractures can, in some conditions, ignite and burn. Such combustion would be visible at night as a glowing point of light. However, sustained free flames from gas seeps are typically associated with specific geological conditions and tend to be stationary rather than mobile. The lateral drift and splitting behavior that witnesses describe is not consistent with the behavior of flames anchored to a fixed gas vent. Gas seep combustion also tends to produce yellow-orange flames rather than the white or bluish-white orbs that the majority of Marfa Light witnesses describe. The combustion hypothesis is therefore a less strong candidate for the anomalous category of lights, even if it might explain some fraction of observations. The range of hypotheses, geological, atmospheric, ball lightning, and combustion, illustrates something important collectively. The Marfa Basin is a place where multiple unusual physical processes are either confirmed or plausible. This is not a location where nothing interesting is happening. It is a location where several interesting things may be happening, some or all of which produce visible light under the right conditions. Untangling them requires distinguishing between events, not treating all observed lights as instances of a single phenomenon. The Hestelin research model, which does exactly this kind of categorical sorting through sustained systematic observation, is the model Marfa needs. Marfa itself is a remarkable place, and the relationship between the town and its mysterious lights is part of both stories. The town of Marfa has approximately 1,800 residents. It sits in one of the most sparsely populated regions of the continental United States, in the high desert at the edge of the Chihuahuan. It was established as a railroad water stop in the 1880s and grew into a small regional center serving the ranching economy of the Trans-Pecos. It had the Army airfield during the war. The film company that used the surrounding landscape for the 1956 film Giant, and several decades of relatively quiet life before it became something more widely known. In the late 1980s and 90s, the artist Donald Judd moved to Marfa and established a large-scale permanent installation of his sculptures in and around a former military compound. The Chinati Foundation became an internationally known destination for contemporary art. Other artists followed. The combination of landscape, light, solitude, and artistic community created something unusual. A small desert town with a global reputation in the contemporary art world. Marfa became known simultaneously as a cattle ranching town, a significant site in contemporary art history, and the home of a genuine atmospheric mystery that nobody had fully resolved. The Marfa Lights fit into this identity remarkably well. They have been interpreted through many lenses: scientific, spiritual, artistic, and touristic. The town holds all of these interpretations at once, without letting any of them fully capture the phenomenon. The official viewing area acknowledges the light's significance without making strong claims about their nature. The local culture treats them with a mixture of pride, humor, and genuine curiosity. It reflects a community which has lived with the lights for several generations. They know the lights the way you know a long-standing neighbor, familiar in habit, not entirely knowable within. From a psychological perspective, the experience of watching for the Marfa Lights is interesting in its own right. You stand in dark desert, at considerable distance from any significant human settlement, watching a flat landscape for unusual light. These are conditions that the human nervous system has associated with heightened attention for most of its evolutionary history. Open ground, low light, unknown sounds, distant movement. In those conditions, the visual cortex is primed to find meaningful patterns. Lights that might be dismissed casually in a busy urban environment demand full attention in the dark quiet of Mitchell Flat. This does not mean that the lights are hallucinations or fabrications. They are documented by cameras, not just human eyes. But it does mean that the phenomenological experience of seeing them is amplified by the conditions in which they are seen. Witnesses often describe the lights as having a quality that goes beyond their physical appearance, a sense of presence or intention that they find difficult to articulate. This quality is almost certainly a product of the viewing conditions and human pattern recognition working in a dark, quiet, open environment. But it contributes to the enduring power of the phenomenon in imagination and memory. Cultures around the world have traditions of mysterious lights in specific landscapes. Will-o'-the-wisps in European marshes, Min-Min lights in the Australian outback, Aliyah lights in the Bengal Delta region of India, Spooklighten in the Netherlands. In most of these cases, the lights appear over flat, open terrain in low-light conditions and are associated with local spiritual or folkloric traditions. The scientific explanations proposed for them share a family resemblance with the explanations proposed for the Marfa Lights. Atmospheric refraction, gas combustion, electromagnetic effects. The cross-cultural consistency of the phenomenon strongly supports the view that these are real physical events. The specific mechanism varies by location and local conditions. Light over dark flat land is a real and widespread feature of the natural world. Human imagination has been interpreting it for as long as we have lived in open places. Marfa is honest about its lights. It does not oversell them as proof of the paranormal. It does not suppress them as embarrassing folklore. It builds a viewing platform, puts up a plaque, and lets the lights speak for themselves. That is, actually, the correct scientific attitude in the absence of a complete explanation. Present the phenomenon. Record the observations. resist the premature conclusion. The lights have not spoken clearly yet. Marfa is still waiting with the patience of a desert town that has been watching the same dark horizon for a very long time. The town's relationship with uncertainty about the lights also models something worth learning. Marfa does not pretend to have resolved the question. The official viewing area does not claim to know what the lights are. The local community does not stake its identity on a particular explanation. The town has found a way to take genuine pride in something it does not fully understand, which is actually a sophisticated and honest position. Most communities, when confronted with something inexplicable in their midst, feel pressure to either explain it away or mythologize it. Marfa has managed to hold the middle ground. This is real, this is here, this is ours, and we do not know what it is. That is a more honest relationship with mystery than most communities manage. There is also a practical lesson in how Marfa handles the tension between scientific credibility and popular appeal. The lights are a tourist draw. The town benefits from that, but the tourist appeal is built on the genuine phenomenon, not on inflated claims. The viewing area does not promise that you will see proof of the paranormal. It promises that you will stand in a beautiful desert at night and look at something that has puzzled careful observers for more than a century. That is honest. That is the actual product. And the actual product is good enough. The lights do not need to be alien or supernatural to be worth seeing. They need only to be what they are. Real, recurring, unexplained, and located in one of the most striking landscapes in North America. That is already remarkable. The honesty makes it more so. The Marfa Lights have not been explained to everyone's satisfaction. After more than a century of observation and published arguments, the question of what produces the anomalous lights over Mitchell Flat is still open. This is worth sitting with rather than rushing past. Science is often presented, especially in popular accounts, as a machine for resolving mysteries. A puzzle goes in and a solved problem comes out. The history of science is full of such examples, mysterious diseases that turned out to be infectious, inexplicable motions in the sky that turned out to follow gravitational laws, strange rays from certain rocks that turned out to be radioactivity. The machine works. It has worked repeatedly and magnificently. The world it has revealed is stranger and more interesting than anything our ancestors imagined. The process that revealed it is one of the most reliable tools humanity has ever built. But science is also a process that takes time. Some mysteries yield quickly when the right tools and the right minds are applied. Others hold out for decades or centuries before releasing their answer. The mechanism of continental drift was visible in the shape of the coastlines for centuries, and yet it took most of the 20th century to establish it as accepted science. Ball lightning has been reported since ancient times and remains without a confirmed physical mechanism. The exact process that produces earthquake lights is still under active investigation. The universe does not organize itself around the convenience of our research timelines. The Marfa Lights fall into this second category. They are not unexplained because the phenomenon is necessarily exotic or impossible. They are unexplained because the explanation is difficult. The location is remote. The events are infrequent. Multiple mechanisms may be operating simultaneously. Scientific funding has not been adequate to the task. The honest answer is still we are not certain. That honest answer should be respected rather than replaced by premature certainty. Whether the confidence goes toward it is just headlights, or it is something paranormal. Both shortcuts fail the phenomenon. Both premature certainties fail the phenomenon. Both choose comfort over accuracy. Better instruments are available now than were available in 2004, when the most cited study was conducted. Spectroscopic analysis at long range is achievable with current technology. Simultaneous triangulation from multiple fixed observation points with GPS synchronization could definitively locate light events relative to known roads on any given night. A properly designed, multi-year study conducted with modern equipment and real institutional support could produce data that would significantly narrow the remaining uncertainty. That study has not been done. The lights are still waiting for science to find the resources to investigate them properly. There is something clarifying about a question that resists easy answers. The Marfa Lights remind us that the natural world is not obligated to reveal itself on our schedule or to arrange its phenomena conveniently for our instruments. The desert kept its lights before we arrived and will keep them long after the viewing platform is weathered and the plaque is unreadable. The lights do not need to be understood. They are not asking for our comprehension. They glow and drift and split and vanish for reasons that are entirely their own. In a landscape old enough to have watched the mountains rise and the inland sea come and go, old enough to have seen the first small mammals find their footing, we are very new here. Our instruments are very new. Our understanding is partial and provisional and will be revised. That is not a cause for disappointment. That is what makes the work worth doing. As you lie in the dark tonight, imagine Mitchell Flat under a clear Texas sky. The temperature is dropping as the desert gives back its heat to the night air. A thin layer of cold air is forming just above the ground. Far to the south, the Chinati Mountains are dark shapes against a sky thick with more stars than most people ever see. The highway is quiet behind you. The desert ahead is quiet. The silence has the quality that only very large, very old, very empty places produce. And then, out over the flat grass, a light appears. White. Hovering. And then it becomes two. And the two drift apart slowly, as if they have all the time in the world. Which they do. They have been doing this since before anyone was here to watch. Since before the roads were built and the cars drove them. Since before the cattle drives and the railroad and the frontier soldiers. Since before any of that, the lights were here, in this specific place, doing exactly this. Whatever they are something. The desert is not empty. The dark is not still. And some questions, the best ones, stay open long enough to teach us how to wait without certainty. Sleep well. The lights are still out there, and the desert is still watching. The Marfa Lights also offer a practical lesson about the value of places where science and wonder can coexist without one destroying the other. The viewing area is not a theme park. It is not a fraud. It is a public amenity built around a genuine unsolved problem in natural science, maintained by a state agency, accessible to anyone who makes the drive. It treats visitors as adults capable of engaging with genuine uncertainty without needing false resolution. That is rare. Most public encounters with science present it as a collection of answers. Marfa presents it as a collection of questions. The questions are more interesting. For the science itself, the Marfa Lights represent a standing invitation. The phenomenon is documented. The location is accessible. The historical record is substantial. The existing studies have narrowed the question without closing it. A researcher with the right background, the right instruments, and a willingness to spend time in the high desert could make genuine progress. The problem is tractable. It has not been solved because it has not received sustained, well-resourced attention. Give it that attention, and it will yield what every natural phenomenon yields to careful investigation. Not necessarily a single clean answer, but a much clearer picture of what is happening, why it happens here, and what it tells us about this corner of the planet. That is all science ever promises. Clearer picture. More accurate maps. Better tools for the next question. The desert has been keeping its lights for a very long time. It will keep them a while longer. When the explanation comes, it will be because someone paid attention long enough to see what the lights were actually doing, rather than what anyone wanted them to be.